All right, so this file, I have fully configured my 2811 routers, and I'm quickly going to just demonstrate what we're doing. I talked about it in the overview, but then when I was rewatching it, it seemed like that was a lot of words. So what we're going to do each time is we're going to see what's going on. We're going to make sure ping works across the other side of the network. So there, I'm pinging the other side of the network, and we're going to want to do two things. We're going to want to run show IP route on the different routers. And we're going to want to analyze that output and figure out what's happening. And hopefully, it's a pretty simple network. It shouldn't be too complex. But here it says, oh, 133.0, that's the subnet that my LAN is in for this particular scenario. That needs to go to 10.243.132.50, which is going to be this router. And your numbers are going to be different in the lab because I'm going to give you different subnets to make. So your numbers will be different. That goes to this router. That goes from this router to that router, right? Because that's the router that's .50. You know, if I look at show IP route on this router, obviously we're not even going to do it. It's going to go across here and then down to there because that's how OSPF works. So we're going to ping. We want to send in a trace route to verify that 10.243.133.2. It should match up what we just got from the routing protocol analysis from the show IP route. So there's that. So we're going to want, I mentioned before, we're going to want to be collecting outputs. At this point, you're going to get this routing table. We're going to get the routing tables off the bottom routers. You don't need to get them all. You can if you want. I don't want them all in the lab report, but if you want to have them for reference, you can. We're going to get the routing table off the bottom router. We're going to label it in our file. We're going to get the trace route results. We're going to label it in our file. So in your file, you should put something like OSPF before failure, and then put the routing table and the trace route, and then you should put a header that says OSPF after failure. So then we're going to create a failure. We're going to send a continuous ping. We're going to send large pings, -L 1400. It's not going to work in the simulator, but in the real world, we're going to do that. Ping-T, we're going to send the pings, and then we're going to create a failure and see how long it takes for the routing protocol to figure out it's failed. So we're going to delete this link, disconnect the link between the switches, and now we should see some missed pings. So there we missed one. We missed another one. So this part is part of what we're doing this week. We're seeing how the routing protocols handle the failure and how long it takes them to detect the failure and start routing the traffic again. Because you might be asked sometime, oh, hey, we want to implement dynamic routing. Which routing protocol should we use? I know you're going to be asked that because that's one of the questions in the lab sheet. So we'll wait. Hopefully it'll start working again soon because OSPF is supposed to be pretty fast with its figuring out things are broken. We can go on the oh, there we go. It's back. I was about to say so it's back now. So now that it's back, we want to go collect show IP route after the failure. And now if we look at the show IP route after the failure, we're now sending the traffic to 10.243.132.54, which that is this router over here. So now, you know, we have this path across the network, and we'll run traceroute to confirm that. And now if we look, it's going across the serial link. So a couple things to notice. If you look at the traceroute up here, we're taking a longer path. There's more hops in this network, but it's faster, right? It should be obvious that it's faster when you're doing the larger pings on the slow network. Here's our path after the failure, and it's shorter, but it is slower once we send the larger pings. Another thing we should look at, if you look at the time to live value on the ping, you see that it's 124 when it's going across a longer path, and it's 126 going across a shorter path. So that kind of reaffirms what we should have learned last week about the time to live field in the IP header, that it gets decremented by 1. So it starts, in this case, it looks like it's starting at 120, 127, right? So the one router, or maybe 128, yeah, probably 128. So it's getting decremented by 1 and decremented by 1 to give us 126. 128, decremented by 1, decremented by 1, decremented by 1, decremented by 1 gives us 124 when it's working properly. So that's another way you can kind of deduce which path is taken based on looking at the time to live value. So that's what we're going to do. I said collect the output, and we're also going to restart the continuous ping, because sometimes when you fix things in a network, it breaks things temporarily. So we're going to reconnect our switches, and then we're going to observe what happens when it comes back up. So we're going to watch this. And the way we can tell, even if we don't miss a ping, if we're looking at this time to live, right now it's 126. So once we start taking the other path, it'll be 124. We can also look in our router at the routing table and see when it changes if we wanted to look at it that way. This is still, link's still not up yet, so we'll just keep watching this until it changes back to 124, and that's when we'll know that it's fixed. So the link is up now, so hopefully our routing tables are doing, our routing protocols are doing what they need to be doing to share the information, so we can get back to the better route. And it's still 126. So again, we want to keep track of how long this is taking. So you want to start a little timer, so we can see how long it's taking, and determine if it's functioning the way it should be functioning based on the way we think the routing protocols are supposed to work. So yeah, so it's still not updated on this router because we're still sending the traffic to the 2811. Wait, that's not right. 33. We're still sending it to the 2811 instead of sending it across the gig network. So, surprise, it's taking this long. Maybe it's this simulator being weird, but it should eventually come back up and start taking the faster link across the network. So that's what we're going to do for each routing protocol that we need to test. We're going to test three different routing protocols, and those are the steps for each one of them. So once we get done with each of the routing protocols, I'm just trying to filibuster till this actually comes back. Sometimes the simulator acts weird. That is 133. So I can ping that other router now. I don't know why they're not sharing their information. I don't know why they're not updating their routing information. Maybe a bug in the simulator. So we'll see if what happens in the lab actually behaves differently. So then once we're done with OSPF, we're going to reconfigure all the routers to switch to a different routing protocol. First, we're going to switch to RIP for the next thing. So what we're going to do with RIP, what we're going to do for that is we're going to reconfigure it by turning OSPF off, no OSPF, no router OSPF1. Then we're going to enable router RIP. We're always going to use version 2. And then we're going to need to put in some number of network statements. So we need to put in network statements that will cover our networks we're attached to. This is the 2811. So we're connected to 10.243.132.0 is one of our networks. 132.32 is one of our networks. And 132.48 is one of our networks. A couple ways you can figure that out. You can look at the connected networks you're connected to. Oh, I forgot this other one, 132.52. You can look at the connected networks from your routing table and get the information from there. So I put all those networks in because those are the networks we're connected to. But if I look at my running config, RIP summarized that along classful network boundaries. So since the class of the 10 network is A, RIP just put 10.0.0.0. So if you only have 10 addresses, 10 dot addresses, you can do it in this way where you just put that. This router up here, we're going to have to do a little more config because we have a different subnet. No router OSPF1, router RIP version 2, and then we're going to have to put in two network statements. We'll do 10.0.0.0, and then 192.168.243.0. So we're connected to 10.243.132.0, which we can summarize, and the routers automatically can summarize as that for us. And then we're also connected to this subnet, which this is a class C, so we need to put the whole 192.168.243.0. If we just put 192.0.0.0, that would not work. So in this case, since it's a class C, we need to put that. So now these two routers should start exchanging routing information using RIP. So we've already learned a couple routes with the RIP. So you need to do that on all four routers. I'm not going to configure all four of them for you. I just did those two to show you how to do your side. Once the other person's up, they will do their side, and then we will do the same things we did with OSPF that we did with the RIP. We'll figure out which path the packet is taking. Hence, it's going to be this one. It should be this one with the RIP. We're going to break this link, and then we're going to see what happens after. So that is pretty much what we're going to do this week. Once we're done with RIP, we're going to switch to OSPF. So not OSPF, EIGRP. So we're going to do no router RIP. And then we'll do router EIGRP1, and then we will do a network statement, much like we did with OSPF. But we don't have to put an area with EIGRP. There's no notation of areas. So same thing, I'll configure this one to make sure the two come up. No router RIP, router EIGRP1, network 0.0.0.0, 255.255.255.255. And then if we do show IP route, we've learned a couple of EIGRP routes already from our neighbor. So that's pretty much it for this week's lab. There is one other thing I failed to mention up to this point. We're going to run a throughput test along with testing our speed with pings. On one of the PCs, you'll start the throughput tester client. On the other side, you'll start the throughput tester server. We'll select TCP only, and you'll let it run for a few minutes to see what the speed of the link is going to be. And I'll show you guys how to do that at the beginning of the lab. So that is that's it for what I'm going to show you with new stuff for this week's lab.